Hello lovelies, in this video the brilliant Mr. B is going to look at multiplying fractions for your GCSE maths. Now this may seem like a simple skill, but it comes up lots and lots and lots, so you need to know it really well, because it will come up in the easiest questions and it will come up in the hardest questions as well. It is not something to be overlooked. However, if you do not pay attention, you will get stuck with this. So get your pens and your papers ready and let's jump in.
At multiplying fractions, and in my opinion this is the easiest part of the fractions topic. So our first question, we have 1/4 and we are multiplying it by 1/2. So what do we do? Well, it's just as straightforward as looking what's on the page and doing it. So we're multiplying. Let's look at the numerators first, the top numbers. We have 1 times 1, which is 1. And then let's look at the denominators, the bottom numbers. 4 times 2 is 8. And that's it. That's our answer. It's as easy as this. I went through that quite quickly, so let's have a look at question 2 and explain it again. So we have 3/2 multiplied by 1/5. So we simply multiply the top numbers, the numerators. 3 times 1 is 3. And we multiply the bottom numbers, the denominators. 2 times 5 is 10. And again, we've got the correct answer straight away. Now, I need to mention that this method absolutely does not work with adding or subtracting fractions. So go back to those videos and just recap the methods from those. With adding fractions, you cannot add the numerators and add the denominators. It doesn't work that way. It's more complicated than that. But with multiplying fractions, you can multiply the numerators and multiply the denominators. So I'm just going to write the answers in. And we don't really need any special working out for this. There's no point me writing the questions down again. So let's have a look at question 3. We have 1/3 multiplied by 1/4. So we multiply the numerators. 1 times 1 is 1. And we multiply the denominators. 3 times 4 is 12. That's it. Question 4. 1/5 times 1/3. So again, numerators. 1 times 1 is 1. And denominators. 5 times 3 is 15. Then on to question 5. 5/4 multiplied by 1/3. So again, numerators. 5 times 1 is 5. And then denominators. 4 times 3 is 12. And again, you can't stress how easy this is. There are our answers. Now, the downside to this is that you've probably just got a lot of meaningless numbers as your answers that don't really mean a lot to you, and that might mean you don't really remember the method that well. So what I'm going to do now is, before we move on to the medium questions, is I'm going to go through what exactly is happening here, look at a few patterns with fractions, and hopefully help you to remember this a little bit better. So we're going to look at 1/4 multiplied by 1/2 using diagrams, try and see what's going on here. We're going to have a look at 1/4 multiplied by 2 as well to compare, and we'll look at 1/4 multiplied by 3 and 1/4 multiplied by 1/4. So when we multiply 1/4 by 2, we are keeping the quarter we started off with. Because we're timesing by 2, we're getting twice as much, so we get an extra quarter. So 1/4 multiplied by 2 is 2/4. What's happened is the numerator 1 has been multiplied by 2 to give us 2, but the denominator 4 has stayed the same. So we're multiplying by a whole number, we're only multiplying the numerator. Let's check that with 1/4 multiplied by 3. So we're going to keep the quarter we started off with, and because we're multiplying by 3, we're going to make it 3 times bigger, so 1/4 will become 3/4. So again, 1/4 multiplied by 3 is 3/4. So we've multiplied the numerator by 3, but the denominator 4 has stayed the same. Now, when I do 1/4 multiplied by 1/2, if I multiply by 2, we're twice as big. We multiply by 3, we're 3 times as big. If we multiply by 1/2, I only want 1/2 of a quarter. I'm going to have to try and colour in half of that section, which doesn't look very good, really. So to make this look right, I'm going to divide all of the sections by half so that I can have a full section coloured in. And that is going to look like this. Now, what fraction do I have there? Well, I have one section coloured in, so numerator is a 1, and there are 8 sections altogether. So a quarter multiplied by a half is 1/8. So when you multiply by a fraction, your answer actually gets smaller, and you might be thinking with multiplication you always get a larger answer, but if you multiply by a fraction like this, it's less than 1, it's going to get smaller. And the math we've actually done here is we've done the 4, the denominator in a quarter, multiplied by 2, the denominator in what we're doing to it, and 4 times 2 gives us the 8. So multiplying by whole numbers, we're going to be making the numerator larger, but if we're multiplying by a fraction, then the denominator is going to get larger. So then if I want to multiply a quarter by a quarter, then I'm going to try and colour in a quarter of a quarter, which is extremely difficult. Now with a half, I had to half each section to be able to fit this in. So with a quarter, I'm going to have to quarter each section. And if I turn all 4 sections into quarters, I'm going to have 16 sections altogether, and I'll have 1 part of that coloured in. So a quarter multiplied by a quarter would be 1/16. Now the last thing I'm going to look at is, let's say rather than doing a quarter multiplied by a quarter, what if we change that from 1 quarter into 3 quarters? Now all that means is rather than having 1/16 in my answer, it's going to be 3 times bigger, because 3 quarters is 3 times bigger than 1 quarter. So I'm going to colour in 2 more quarters the best I can with this diagram, and that will mean that my final answer won't be 1/16, it's going to be 3 times bigger, it will be 3/16. So when you multiply the denominators, you're handling cutting up into smaller parts so you can fit in your answer, and when you multiply the numerators, you're dealing with numbers which are bigger than 1/2 or 1 quarter. You might want 2 quarters or 3 quarters. So you want those larger fractions compared to 1 quarter, you're going to have to multiply. So moving on to the medium questions, we're going to continue using our method, which was we're going to multiply the numerators, the top numbers, and multiply the denominators, the bottom numbers. So question 1 is a half times 2/3. So let's multiply the numerators. 1 times 2 is 2, and then multiply the denominators. 2 times 3 is 6. Now the reason why these are medium questions is we can simplify our answers, and since 2 and 6 are both even, I'm going to be able to divide by 2 and get 1/3. 2 divided by 2 is 1, and 6 divided by 2 is 3. Question 2, we have 3/5 multiplied by 1/3. Let's multiply the numerators. 3 times 1 is 3, and then multiply the denominators. 5 times 3 is 15. Now to simplify, these numbers are odd, so we can't divide by 2. Let's try the next number up. Let's try 3. 3 divided by 3 is 1, and 15 divided by 3 is 5. So that works, and there's our final answer. Question 3, we have a half multiplied by 7/3. Let's multiply the numerators. 1 times 7 is 7. Let's multiply the denominators. 2 times 3 is 6. Now with this one, we can't simplify by dividing. 7's a prime number, we can't divide 6 by 7, so we can't do that. But 7/6 will be the same as 6/6 plus 1/6, and 6/6 would be a whole one. So that would give us 1 whole one and 1/6 left over. So sometimes you can simplify by converting a top-heavy fraction, like 7/6, where the numerator is larger than the denominator, and turn it into a mixed number, like 1 and 1/6. Moving on to question 4, we have 3/2 multiplied by 5. Now, a nice little tip for questions like this is that you can write any whole number as a fraction, and all you have to do is give it a denominator of 1. Fractions also can describe divides, and 5 divided by 1 is 5, so that's going to stay the same. Also, again, we come back to our analogy of pizzas with this, and if you've got 3/2, then you can imagine you've got 2 pizzas that have been cut up into halves, and you've got 3 really big slices left. Now, when we're saying 5 whole pizzas, you might just come out of the oven. It's not been cut into any slices at all, so you would write that as 5 over 1 because you have 5 pizzas, and how many slices are they cut up into? Well, you haven't cut them up, so each pizza is effectively one giant slice, the whole pizza. So any whole number can be written as a fraction, just give it a denominator of 1. So then we can do this question quite easily using the same method. We can do numerators, 3 times 5 is 15, and then our denominators, 2 times 1 is 2. Now, I just mentioned that fractions and divides are the same thing. So when we have 15 over 2 and we want to simplify it, that is the same as saying 15 divided by 2. And 15 divided by 2 would be 7 remainder 1. Now, we don't want to write remainders in secondary school. So what we do with remainders is we just write them with a denominator, and it's the denominator I've been working with, which was over 2. So our answer to 3 halves multiplied by 5 is 7 and 1 half. So for question 5, we have a whole number 2 multiplied by 5 quarters. So we imagine that 2 is the same as 2 over 1. Then we can multiply our numerators. 2 times 5 is 10. And multiply our denominators. 1 times 4 is 4. We have a top-heavy fraction. And there's a couple of ways of doing this. We could say, well, 10 over 4 would be 4 fourths plus another 4 fourths plus 2 fourths, which would give us altogether 2 whole ones and 2 fourths. Alternatively, you could use a method we used for question 4, and we could say, well, 10 over 4 would be the same as 10 divided by 4, and 10 divided by 4 would be 2 remainder 2. And then we just write our remainder over the denominator we're working with, which was the 4. So there's 2 ways of getting that mixed number. Finally, you might have spotted the fraction portion of the mixed number can be simplified. 2 over 4, they are both even numbers. We can divide those by 2, and that will give us 1 half. 2 divided by 2 is 1, and 4 divided by 2 is 2. Now, before we move on to the hard questions, there's one important thing we need to talk about, which is the difference between equivalent fractions and multiplying fractions. So to show you what I mean, I'm going to take the fraction 2/5, and I'm going to do 2 different things to it to show you the difference. So the first thing I'm going to do is multiply it by 2. Now this is using the method we've been using the entire time, so we multiply the numerators, so 2 times 2 is 4, and then multiply the denominators. Remember that whole numbers have a denominator of 1, so 5 times 1 is 5, and what we have done here is we have multiplied. And this is using the method we've been using the entire video. Now, another thing you might have seen is equivalent fractions. And you might have seen people, and I know I do this as well, saying, oh, we're going to multiply this fraction by 2, we're going to multiply the numerator by 2, and the denominator by 2. So 2 times 2 is 4, and 5 times 2 is 10. So we have a different answer, and what we have found here is an equivalent fraction. So what's the difference between these 2 things? Well, in an equivalent fraction, 2/5 is exactly the same fraction as 4/10. They are the same quantity. So again, coming back to talking about pizzas, if you had a pizza cut into fifths and you had 2 slices, that would be the same amount of food from a similar sized pizza, or same size pizza, with 10 slices cut out, and you eat 4 slices. So eating 2 medium-sized slices or 4 smaller slices would be the same amount of food. Now, when you're multiplying fractions, and we start off with 2/5, when we multiply it by 2, we have 4/5, which is not the same quantity. It is twice as big. So be very, very careful when you're saying that you're multiplying fractions. Are you actually multiplying the quantity and getting a brand new quantity, which is what we're doing today, or are you multiplying both sets of numbers and just changing how many slices your fraction's divided up into, but keeping the same quantity, which would be equivalent fractions? Now, moving on to the hard questions, you'll notice that now we have quite a lot of mixed numbers here. And just like with adding and subtracting fractions, the methods being taught here only work on fractions. And if you have a number that isn't a fraction, such as a whole number or a mixed number, you should change them into fractions first. So for question 1, we have 1/10, and we are multiplying it by 6. And we already went through this with the medium questions. Any whole number can be written as a fraction, give it a denominator of 1. So let's multiply the numerators. 1 times 6 is 6, and multiply the denominators. 10 times 1 is 10. Once you get your final answer, just think about if you can simplify. I see that 6 and 10 are both even numbers. We can divide it by 2. So 6 divided by 2 is 3, and 10 divided by 2 is 5. Now, given what I just went through the medium questions, it's very important to think about the language I'm using here. I said divide by 2. Now, I haven't reduced the quantity by half, like dividing by 2 has what we'll do usually. What I've done is I've divided the numbers by 2, the way the fraction is being represented. So again, think about pizzas. If you have a 10-slice pizza and you have 6 slices, what you could do is get a bit of cheese and you could stick together some of those slices, and you could turn your 10-slice pizza into a 5-slice pizza by sticking pairs of 2 slices together, and there you'll have 3 slices out of 5 slices. But 6 out of 10 slices and 3 out of 5 slices is exactly the same quantity. It's just divided into less pieces. So I'm not actually dividing by 2. When I say divide by 2, I'm just reducing the number of slices a fraction is divided up into. So 1/10 multiplied by 6 is 3/5. Next, we're going to look at question 2, which is 1 1/4 multiplied by 1 1/3. And like I've been saying, all the methods we've learned only work with fractions, and these are not fractions, they are mixed numbers. So we need to turn both numbers into fractions. So with 1 1/4, one whole one would be 4 quarters, and then we have one more quarter, so that'll give us 5 quarters. And then 1 1/3, well, a whole one would be 3/3, and then we have the extra third, so that'll give us 4 thirds. Alternatively, you might have seen this on the subtracting fractions video, we are taking the whole number, we are multiplying it by the denominator, and then we are adding on the numerator. So if we have a look at 1 1/4 again, the whole number is 1, we're multiplying that by the denominator 4, and then we're adding on the numerator 1, which will give us the 5, so then it'll be 5 quarters. Now we've done that, we can multiply, so let's multiply the numerators. 5 times 4 is 20, and multiply the denominators. 4 times 3 is 12. Now again, we have even numbers, so let's simplify. So let's divide these numbers by 2. 20 divided by 2 is 10, and 12 divided by 2 is 6. Those numbers are still even. Let's divide by 2 again. Always double check, can you simplify more than once? 10 divided by 2 is 5, and 6 divided by 2 is 3. And then finally, this is a top heavy number, 5/3. So 5/3 will be the same as 3/3 plus 2/3. So we have a whole number there, giving us 1 2/3 as our answer. And just a reminder, it's an alternate method at this point when you have 5/3. Fractions and divides, 5/3 will be the same as 5 divided by 3. And 5 divided by 3 is 1, remainder 2. And then write your remainder with the fraction as your denominator. So it's over 3 in the question, it'll be over 3 in the answer. So 1 1/4 multiplied by 1 1/3 is 1 2/3. So moving on to question 3, we have 3 7/12 multiplied by 1 1/4. So first, recognising that we have mixed numbers and this method won't work with mixed numbers, we need fractions to use our method. To change mixed numbers into fractions, we're going to do the whole number multiplied by the denominator and then add on the numerator. So 3 times 12 is 36, and 36 plus 7 is 43, and that'll be over 12. Then we'll do that with the second fraction as well, whole number of 1 multiplied by the denominator 4, and then add on the numerator, that will give us 5, and it'll be over 4. The denominators are not changing. So now we can use our method. So let's do the numerators first. 43 times 5. Well, 40 times 5 would be 200, and 3 times 5 is 15. So that will give us 215. And then the denominators, 12 times 4. So 10 times 4 is 40. 2 times 4 is 8. That will give us 48. Now we have a top-heavy fraction, so we might like to simplify it. So 215 divided by 48. You might want to use a written method here. I'll try and use a bit of mental arithmetic. I know that 4 50s will fit into 200, so 4 48s will definitely fit into 215. Then what's my remainder? Well, if 4 50s fit into 200, then 48 is 2 less. So that 2 less, I've got 4 of those, which is 8. And then that's into 200. I've actually got 215, so I've got 15 extra. So that 8 and 15 will make 23, and it'll be out of 48. Now, can I simplify this? Well, I remember that 23 is a prime number. I can't divide 48 by 23, so I'm going to have to leave it there. So the answer to 3 and 7/12 multiplied by 1 and 1/4 is 4 and 23 over 48. Now for question 4, we have 3 and 2/9 multiplied by 3 and 1/6. So again, we can see that we do not have fractions, we have mixed numbers. Let's turn them into fractions. We'll do the whole number multiplied by the denominator, add on the numerator. So 3 times 9 is 27. Add on the 2 will give us 29 over 9. Then for the second fraction, whole number multiplied by the denominator, 3 times 6 is 18. Add on the numerator, 19, and that'll be over 6. So now we're going to multiply the fractions. Let's multiply the numerators first. Now for 29 multiplied by 19, I personally would use a written method. I use column multiplication. Now to keep this video as simple as possible, I'm not going to go through that here, so go back and watch a column multiplication video. But if you spend a bit of time doing that, you should get 29 times 19 is 551. And then the denominators, 9 times 6 is 54. Then we have a top-heavy fraction, and we can use a division method to do that division. And again, I'll try and keep this video simple and not put too many methods on the screen. We'll try and keep it to the fractions. So 551 divided by 54. 10 whole 54s go into 551, and its remainder 11. And my fraction is over 54. Can I simplify this? Well, 11's a prime number, so I can't really divide that down. Can I divide 54 by 11? No, I can't, so that will be my final answer. 3 and 2/9 multiplied by 3 and 1/6 will be 10, and then 11 over 54. If you think yourself, well, these questions are quite large, I'm panicking about this, it's quite a lot to do. If this wasn't an exam, it'd be worth loads of marks because you're showing fractions methods and multiplication methods and division methods, but I think the questions on the exams are a little bit easier than this, so we'll just test you a little bit just so you're fully prepared for what you find on exams. Now moving on to question 5, we have 3 and 6/8 multiplied by 2 and 2/8. Now you might be looking at this already and going, oh no, we're going to have these huge numbers again, like the last two questions. So I'm going to show you a little technique you can use to try and keep the numbers under control. So what I'm going to do, before I change these mixed numbers into fractions, we're going to simplify the fractions. Now you can't always do this, but I can with these. So the whole number's going to stay as it is, but 6/8, well, they're even numbers. We can divide those by 2, and we would get 3/4. We do the same thing with 2 and 2/8. The whole number will stay the same, but 2/8, both those numbers are even. We can divide those by 2 to give us 1/4. So both of these represent the same numbers, we'll get the same answer, but because we simplified the fractions, it's now going to keep our multiplication under control, and hopefully this will be a little bit easier than the last two questions now. So let's turn these into fractions. So whole number multiplied by the denominator and add on the numerator. 3 times 4 is 12, plus 3 is 15. That'll be over 4. And then for 2 1/4, 2 times 4 is 8, plus the 1 is 9. Now the fractions, let's multiply the numerators, so 15 times 9. So 10 times 9 is 90, and 5 times 9 is 45. So 45 and 90 is 135, and denominators now, 4 times 4 is 16. So simplifying the fractions in the question made that multiplication quite manageable. If we hadn't have done that, then we would have to do a written method for a larger multiplication and then simplify it later on to make up for it. The division's still a little bit tough, so use a written method for this, and 135 divided by 60 will give you 8, remainder 7, and then that 7 will be over the 16. Now think about simplifying. 7's a prime number, so that's not going to divide down. Can we divide 16 by the 7? No, we can't. So there's our final answer. 3 and 6/8 multiplied by 2 and 2/8 is 8 and 7/16.